Hello and welcome to lesson 2 of momentum and impulse. So kule video previous momentum and impulse we went through the exam guidelines lapho siqale khona ama definition of the important terms ku topic momentum and impulse, right? So the advice ukuthi nawufunda ama definition wafunde from ama exam guidelines ngoba kungiwo abawasebenzisako isikhathi esiningi kuma memorandum, right? So need ukuthi revise ama definitions. We went through definition of momentum, define ukuthi momentum is a vector quantity, right? It has both magnitude and direction, and we looked at the formula of momentum, and then discuss in Newton's second law of motion in terms of momentum, and then we went through the definition of impulse, and then sachaza ne impulse momentum theorem, which is this formula here, F net equals to delta F net times delta t is equals to the change in momentum. Okay, and then discuss define a closed system, and then define the principle of conservation of linear momentum, and then we also discussed collisions, elastic and inelastic collisions. Ngabuye ngadefine nokuthi kinetic energy kwenzekani ngayo in elastic collisions, and then kwenzekani ngayo in inelastic collision, right? So that was lesson 1. So today sizochubeka la sigcine khona, and then just to refresh, let us sort of go through this mind map, an overview of momentum and impulse, right? So ku topic momentum and impulse, you can use sort of this mind map to highlight the key important points or the important terms, right? We defined momentum as an object's product. We define momentum as the product of an object's mass and its velocity. The mass of an object is measured in kilograms and the velocity is measured in meters per second. The formula for momentum is this one: P is equals to mv, and then the unit of momentum is kilograms meters per second. Okay, momentum is a vector quantity, therefore direction is important, and then momentum depends on mass and velocity. Momentum is directly proportional to mass and velocity, meaning if we increase mass and keep velocity the same, then the momentum will also increase. Or if we increase velocity and keep the mass the same, then momentum will increase. Okay, okay, and then we also looked at change in momentum, which is indicated by delta p. So change in momentum is equals to the change is equals to the difference in final momentum and initial momentum. Change in momentum also depends on the initial velocity, right? So delta p is equals to the final momentum minus the initial momentum. The change in momentum is equals to the final momentum minus the initial momentum, and the change in momentum depends on the change in velocity. where the change in velocity is the initial velocity minus the final velocity minus the initial velocity. Okay. And then we looked at the law of conservation of linear momentum. The law of conservation of linear momentum states that the total linear momentum of an isolated system remains constant in magnitude and direction. Then this will be used to solve our questions are related na linear momentum. Okay, and then we discussed Newton's second law of motion in terms of linear momentum. It is stated as follows. The net force acting on an object is equal to the rate of change of momentum of the object in the direction of the net force. Right, therefore we have this formula. F net is equal to delta P over delta T. Delta P over delta T is the rate of change in momentum. Rearranging this formula, we get impulse. Impulse is the product of the net force times the time the net force is applied on an object. Impulse is the product of the net force and time the force is being applied on that object, and is equals to change in momentum. Okay, the SI unit for impulse is Newton second. And then we looked at elastic and inelastic collisions. We say in an elastic collision, total kinetic energy is conserved, and in an inelastic one, total kinetic energy is not conserved. Okay. So today is always discuss ama examples, right? So in my example is ngifuna so solve lana, right? So we have a question saying determine the momentum of a 6 kg object moving at 5 meters per second to the right. Question A, Loyo, right? That's question A. Okay, so lapha question A bathi determine the momentum of a 6 kg object moving at 5 meters per second to the right. Okay, so determine the momentum, right? Doctor Maguti is choose a direction because we are dealing with a vector quantity. In momentum it's a vector quantity, right? Therefore sizoti choose the direction to the right as positive, right? Choose the direction to the right as positive, and then we know what the formula linear momentum is P is equals to mv, right? So lapha basinikele imass ye object ukuthi it's 6 kg, right? And then sizoyi times ne velocity, which is 5 meters per second to the right. So because we choose a direction to the right, sizothi times positive 5. So nanoma singampadi plus loya lapha. Okay, times positive 5. Okay, so ku A sino 30 kilograms meters per second to the right. Momentum there, right? And then question B bathi a car has a momentum of 20 kilograms meters per second. Calculate the car's new momentum if its velocity is doubled. So the formula of momentum is P is equals to mv, right? So if the mass of the car is doubled, then what will happen to momentum, right? So currently mass yekoloyi m, let's say it's m, and then if we double this sizoba no 2m, right? So lapha ku formula ye momentum sizoba no, calculate the car's new momentum if velocity is doubled, sorry, not mass, if velocity is doubled. If the velocity is doubled, a car has a momentum of 20,000 kilograms meters per second. Calculate the car's new momentum if its velocity is doubled. If velocity is doubled, what will happen to momentum? So the momentum of the car is 20 kilograms meters per second, right? So this is the momentum, and momentum is equals to mass times velocity. So if we double the velocity, then we'll have 2 mv. If we double the velocity, then momentum will also double, because this is momentum p. So when we calculate the car's new momentum, if velocity is doubled, we'll say the new momentum is 2 times the initial one, 2 times the initial momentum, right? So it will be equals to 40,000 in the direction of the velocity, right? In the direction of the car's velocity. And then question C, what he calculate the velocity of a car if its momentum is 60,000 kilograms meters per second and its mass is 2,000 kg. So again, the formula of momentum is P is equals to mv. Basinikele ukuthi momentum is 60,000 and then mass is 2,000. Sifuna velocity. So velocity will be equals to 60,000 divided by 2,000. It will be 60 meters per second in the direction of the car's momentum. Right. So yeah, my question, my example is now ngilawo, and then let's do more examples. Okay, let's look at another example. So lana bathi a 500-gram soccer ball is kicked at 12 meters per second towards a wall. It rebounds off the wall at 2 meters per second. Calculate the change in momentum. So la, okay. So into eyenzekako la ukuthi kunebhola, ibhola baliragela eboteni, right? Let's say this is a wall, and then at first it's moving at 12 meters per second towards the wall, and then after it rebounds liyabump eboteni in the opposite direction, libuyela at 2 meters per second. Yeah, so they want us to calculate the change in momentum. So because momentum is a vector quantity, it means it has magnitude and direction. So let's choose the direction towards the wall as positive and the direction away the wall as negative. So this velocity after the ball bounces off the wall is negative, right? So the formula for changing momentum is delta p, okay, so it's delta p is equals to final momentum minus initial momentum, right? Where final momentum is the mass of the ball times the final velocity, right? So the mass of the ball is 500 gram. If you divide 500, because SI unit in mass it's kg, if you divide 500 by 1000, you'll get it's 0.5 kg. It's 0.5 kg times the final velocity, which is 2 meters per second, but then in the opposite direction, right? So this is negative 1 kg meters per second, or it's 1 kilograms meters per second away from the wall, right? And then initial momentum is the mass of the let me write the formula first. The mass of the ball times the initial velocity. The mass of the ball is 0.5 kg times the velocity. The initial velocity is 12 meters per second towards the wall, right? So the initial momentum is therefore 6 kilograms meters per second towards the wall, right? Therefore the change in momentum is equals to the final momentum minus the initial momentum. The final momentum is that guy. It's negative 1. The initial momentum is this guy, it's 6. So negative 6 minus negative 1 minus 6, it's negative 7, right? It's negative 7 kilograms meters per second. So therefore the change in momentum is 7 kilograms meters per second away from the wall. Okay, that's it. Okay, so let's look at another example. Anabati, a golf ball with a mass of 0.1 kg is driven from the tee. The golf ball experiences a force of 1000 newtons while in contact with the golf club. and it moves away from the golf club at 30 meters per second, right? So but you calculate the time during which the golf club was in contact with the ball. So lana sizo-aplya i-impulse momentum theorem, right? Khumbula ukuthi impulse momentum theorem ithi impulse is equals to the change in momentum, right? But then thina siyazi ukuthi impulse is the product of the net force. Siyazi ukuthi impulse is the product of the net force multiplied by the time that net force is being applied on the object. Things ukubhala kuhle. Okay. So impulse momentum theorem ithi impulse is equals to change in momentum, right? But then impulse is equals to F net times delta t. F net, the force being applied on the object, and delta t being the time for which the force is being applied. So F net times delta t is equals to change in momentum, right? So we are given the net force and we can calculate, but it's calculated with delta t. We are given the net force and we are given the mass of the object and the final velocity, so we can calculate change in momentum. So change in momentum, let us calculate change in momentum first. Change in momentum is equals to final momentum minus initial momentum. Final momentum is the mass of the object times the final velocity. Initial momentum is the mass of the object times the initial velocity, right? Then we can factorize mass and then calculate change in velocity. So the mass of the object was nikezile, it's 0.1 kg. Final velocity is 30 meters per second. Initial velocity is 0 because initially the ball is stationary, right? So initial velocity is 0. So lapha change in momentum will be 0.1 times 30. 30 times 0.1, so it's 3. It's gonna be 3 kilograms meters per second, right? Away from the t. All right. Okay, so now we have change in momentum. We can calculate delta t. So F net delta t is equals to change in momentum. Change in momentum that will calculate F net is now 1000 newtons times delta t is equals to 3. So delta t is equals to 3 over 1000. So the time the golf club is in contact with the ball is 0.003 seconds. Okay, yeah, ukhumbule ukuthi this is sort of like application of Newton's second law of motion in terms of momentum. Asithi F net is equals to the rate of change in momentum, right? And then now rearrange a formula uzoba ne impulse momentum theorem. Okay, yeah. Okay, so let us look at another example. The following graph shows the force exerted on a hockey ball over time. The hockey ball is initially stationary and has a mass of 150 grams. Calculate the magnitude of the impulse of the hockey ball. So this graph shows the force exerted on a hockey ball over time, right? So here on the vertical axis we have the force, and then on the horizontal axis we have time. So but calculate the magnitude of the impulse of the hockey ball. Khumbula ukuthi impulse is defined to be the product of the net force and time, right? So we have a graph showing the force exerted on a hockey ball over time. So we have force and we have time, and impulse is equals to the product of net force and time, so we can calculate impulse. Okay, so the net force, so so this is gonna be the net force and time. So to calculate impulse, from this case we'll calculate the area of this triangle. The formula area is half base times height, right? Half base, what is the base? The base is 0.5 and the height is 150. So if you say half base times height, uzoba no 37.5 newtons second, unit of measure, impulse. Okay. Right. Okay, so yeah, I think that's enough for this lesson. Until the next one.